Right, so this is for the recording, implicit differentiation. We just differentiate our x cubed to get 3px squared, as p is a constant. This next part, we must use our product rule, which is here. So that should be our next line. Now this 6y dy dx is for this. Remember, differentiating 26 is 0. We group our dy dx terms. So I've grouped this here, and I've brought the 3px squared and the qy over to the other side. Now this, you can see we're on the right track because that looks exactly like this. And obviously our last step, we divide out by our qx and 6y. That is our answer, where a, b and c are integers to be found, and you can see what those would be. Right, do we have any questions? Let me know. Right, Anastasia, I'll wait for you to finish typing so I can answer. Now, think about this. You've got this point, it lies on C, Anastasia. The normal to C at P has this equation, so it's at the same point. So what we can do is, you've got to remember, dy dx is our gradient function, so we can find the gradient of the tangent if we substitute -1 and -4 into here. And this is what students will find tricky, the part B part. So at this point P, you sub in your values into your dy dx, and that makes your tangent. And then you know your m1 times your m2 should equal -1 for the normal. Right, I've just simplified the terms a little bit. Yeah, so we're using this because it gives you this equation as well, right? Hopefully that unlocks it, because we can't do anything with this right now because we have unknowns. But this, we can rearrange it into form of y equals mx plus c to get our m. All right, so you can clearly see I've minus 19x to get 19x minus 1, 2, 3. It is 26y. So I divide by 26, and then can you see I've got the gradient at the normal? So if we're using the normal, this is our m, that's minus 19 over 26. That's our normal. So of course our tangent is what? The negative reciprocal, which makes it 26 over 19. And hopefully that means we can put this right up here. All right, and then there's a bit of solving to do from here, right? We can rearrange. Now that unlocks that. Let me know if you need another tip. And you think your way through it. And I don't mind if you don't know, because this is a skill you might have to spot in the future. But well done for asking the question. And hopefully someone will ask the next question about, well, where do we go once we've simplified that? Because there's still two unknowns, Q and P. Oh, well done. Yeah, you sub the coordinates back in because this is it. That's how you unlock it. Well done, Alice. This is a thinking skill we need to get that extra 5 out of 5. And you can see how people get unstuck there. So a lot of all your skills from year 12 and year 13 applied. Right, I've rearranged it to this. It doesn't matter how you rearrange it. You might do it a different way. And then I've said use the equation of the curve. We've got this. We sub in our coordinates. And I'm sorry, I should have wrote y equals -4 there. That should say y equals -4. And we get our second equation. And then you solve simultaneously. And I'm going to heart that statement. And well done. And if we don't follow those steps, it's hard to unlock the rest of the question. But hopefully, doing bits of it, you can earn some effort marks. And I would rate this question grade B to A. Well, actually, the first part is probably like almost grade B to C, really. But it's this part here, linking all the skills and application, which really makes it grade A, I would say, because of the steps. And let me know in the chat box what you get for Q and P. Let's not fall at the final hurdle. Yes, that is correct. Got 2. So because I've run out of space, I'll do the simultaneous equation here. Samaya was typing, but I think you've cancelled the message. Yeah, we just match any coefficient you want, P or Q, I mean, any variable, not coefficient. I've matched the P's, plus them together, and I've jumped a step once I know what Q is. It's easy to find P. So that is really, really good. Right, so do we have any questions on this, or can we move on to the next one? The next one is very nice and straightforward. Hopefully you can do this with good pace. Right. If you're on your phone, you can take a screenshot of this. If you're on a computer, you can use a snipping tool and just snip and copy the whole picture out. If you need me to go back to this, I will, but I don't think there's any question, so I will move on to the next one. Right, there is 2 here, just in case people get ahead of themselves, as I'm trying to not have you waiting around. This one is very nice. It was a question 30 in June 2011, but it's still applying those skills with Lun. And can we really make sure we get that right? Is the dy dx supposed to have x and y in it? Right, are you talking about, right, I assume you're on question 2. So what you're going to get here is 1 over y dy dx, and obviously you differentiate this side as well using the product rule, if that makes sense. I hope this answers your question. That's a product rule for this side. So someone's boiling the kettle. And so we'll get dy dx on just one side. And obviously we multiply out by y, if that makes sense. So then we get dy dx on one side. There's e and none cancel out. So what you have to do for this question, or when you find a y value. So there's a way to do this, because find the point of the curve when x equals 2. So I think you're almost there. So once you multiply out by y, be careful, the y, common error is to put the y next to the x just because we're in a rush, but that's 2y ln x and 2y. We multiply both terms by y. Now you can factorize this here, because now you're thinking, why have I thrown in a 2 here? But it says when x is 2, so we know x equals 2. So once we have this, we can get ln y from the beginning equals 4 ln 2. So I hope this is going to help us. Right, because we obviously do need the y coordinate. That's what you're asking, right? So we have to use this original value here. Can you see we put 2 into our original? Well, we can get ln y into terms of x, because 2x, x is 2, that's 4. Use the power law. You see ln y equals ln 16, so y equals 16. And then from there, we can finish. And give the exact value. Well, we sub our y and our x value in. So what I mean with these types of questions is do what you can and think, oh, what am I missing? What do I need to find? How can I find it? The clue is always look back into the question. What can we do? If there's nowhere you can go is, well, what happens if I put x equals 2 here? Can I find value of y? Which you can. And this is what you do in a lot of questions, if you think about it. Right, that is good if you got there at this stage. That is super. Well done, Samara, as well. No problem. So this, a question 15, this was a question 15 in October 2020. So that's right at the end of the paper. That is technically supposed to be the most challenging question. All right, we're doing very well for time. You're doing this in good time. Well done.
Identity, and then when you differentiate it, you get sec squared y, and you can plug it back in.
Well, I used the product rule, but it's not working with the product rule. I literally did what Sir's doing right now. It's not working.
Oh, he's back. Hello.
Like, I don't really understand what to do from here.
You use the identity. So you know the normal equation x squared tan y equals 9.
Yeah, but why do you make it equal to 0?
Dude, I don't know what he's doing, but that's how I was solving it.
I don't know, I'm a bit confused.
Oh, we're having fun, guys.
You know he's on it, by the way.
I think he's muted.
Yeah.
Oh my God, I muted myself. Right. Oh, right. I was sorry. I did not realize. I was like been talking to myself for 2 minutes. So, yeah. So for some reason, my call just dropped out. So I didn't leave. It just dropped out. So I had to rejoin. So I could hear what you're saying. So Anastasia, are you happy that you got up to here?
You know, I got up to that part, but I just don't know how. Like, I have no idea how they got to minus 18x over. Yeah, I just don't know how they.
Oh, okay. So that is fine. And sometimes actually it's easier for you to just use the mic, but just make sure you turn it off afterwards each time, because obviously the call gets worse with lots of mics open. So I think the TIFF, right. So that is the hard point here. This is why this is a question at the end. Can you see actually tan y? Well, we don't know what tan y is, but how can we make it easy for yourself? Can you see in this original question here? I've highlighted it. Tan y is 9 over x squared. Can we see that? Okay, I'm assuming we can see that, but mic's all turned off. So then we can do something with this now, right? But this is something we're going to have to use a bit later, right? So if we're doing that in terms of y, obviously that is 1 plus tan squared y. All right. Which is, this is why you can see it's a very hard question, right? Because we know tan y here is 9 over x squared, so our tan squared y must be this. Are we following? Let me open the chat box because I can see someone's chat. Could that be? Okay, that's fine. So yeah, wait there. Let's just carry on from here, because this is why you can see it's a question 15. This is, I would say, A-star level question, because there's a lot of things you have to spot and apply. And I can see essentially we got stuck here, which is totally understandable. Right. So obviously I'm going to simplify that to make it nicer for us. So we can put this all into here now. All this information. And Alice, if you got that, that was impressive. That is really well done, Latif. That is actually super impressive. I told you, you should be going for A. We could do it. I told you this lesson will benefit everyone. No matter what grade. So we can simplify this to minus 18x. Think about it. If we're dividing by x squared here, then we can join that to this question here, to the denominator. All right. So then we get this. Now, this bit could be tricky for some people. Hopefully that makes sense when we expand that. X to the 4, these x to the 4s will cancel out. So we've got a nice term there. Now, I think you got stopped. There's 2 ways to do this. This is the mark scheme way. But prove that this is a point of inflection. So do we remember what an inflection point is? I might draw it. Where's my pen? So inflection points, and you might have forgotten this rule, but if you're getting most of these marks, well done. So let's see what we can draw. Here we go. So inflection points are like that. Or like that. So because if you've got your dy dx, can you see before that point, so this is the point root 427, if you've got a gradient that's positive and positive before and after, that has to be a point of inflection, because obviously the other points are like this, right? Or like this, like a proper turning point, it's maximum or minimum. Or if you've got a negative gradient, because that's going downhill to negative gradient, so use a value to the left and right of this, and if you can show that, I think that's a valid way to show it's a point of inflection. That's not in the mark scheme. The mark scheme version says to do your second differentiation, which is, well, just 3 marks. It doesn't quite make sense to me because it's only worth 3 marks. Maybe it's a question at the end. So you just use the quotient rule. And then when you sub this in, and this is the rule for inflection, when you do the second derivative, so when x is less than 4 root 27, so value less, the second derivative is less than 0. When x equals this, then we know that equals 0. So technically, when you sub this value into here as well, you'll get 0. Right, the gradient will be 0. And then when it's greater than 0, when you plug in this, and that should be when x is greater than 4 over 27, it's greater than 0. So with the second derivative, you might not remember this rule, it's a long time ago. When you have difference, when it's less than to greater than or greater than to less than, then that is a point, proves that it's a point of inflection as well. Well, technically for dy, when it's just dy dx, Alice, answering just all your question, can you see the gradient is actually goes from positive to positive or negative to negative for a point of inflection? But when it's the second, derivative, this is the rule. But I think just using this is a bit easier, but this is a lot for 3 marks. Yeah, so that is for dy dx. That is for d2. That's for the second derivative. That is one of the rules. But I mean, to be honest, if you get a couple of marks here, essentially, if you're getting, I did say that's question 15. If you're getting 7 out of 7 here, you probably be getting A star, right? To be all those factors. All right, so that is good. If you got most of the way there, this was, I would say this is an A-star type question because there's a lot to it. But if you got loads of marks, got even the first 4, that's really good for the last question. Right, that is question. So this will probably be our last question. So this appeared question 9, 2018. Now, what I'm going to say is, oh my God, look at this picture. It looks very confusing. Right, but essentially is, don't worry about it. Look at the word, just read the question. Look, this looks like it's implicit because there's x's and y's. So just use your normal skill. Let's get those first 4 marks. In some ways, I prefer these show that ones because you know where you need to get to. And hopefully, you know, that is still, yeah, question 9. So it's in the second half of the paper. That's probably, you know, technically you're getting this right, you're getting close to an A. Or you'll be on a, well, you'll definitely be on a B. So just do what we can. This is easier than the last one. Parts B and C is the thinking skill part. We really see is, but it's only 1 mark. Now, some of you on part B, that thinking skill, yeah, is a little bit tricky to unlock that question. Okay, just spotted the question being asked. How do you start B? Good question, and that's what you've got to realise to ask once you've given it a little think. So I'm going to catch us up to where we should be at. And if you've got part A, that's still a very important 4 marks, recognising this is implicit. Not all people spot that's implicit, but this is very nice question because it's a show that this kind of skill should be in our pocket right now. And obviously you get a minus here, but you just if it wasn't correct, so we got to there. So now, Samara, to answer your very good question, this is the application bit, which is tricky. Your point P and Q, this is your clue. The clue is always in the question, so it's an asymptote. So what do we know about asymptote is that these points actually do not ever touch it, all right? They don't touch. So what information have we got that we can apply to this question? What can make this an asymptote? Right, let me just check the question. Are the lines P and Q normals to the curve? It doesn't say it. I mean, if anything, they look like they could be tangents to the curve, but it doesn't say it. But that is a big clue because it's related to gradient. So, oh yeah, so not almost, not quite x equals 0, because x equals 0, it doesn't mean this will be undefined, because you still get, that means you'll be saying the gradient is 1 over 3, right?
So,
that gradient is clearly not 1 over 3. Yes, Latif.
may I leave now? I'm gonna go break my fast.
Oh, okay, of course. Yeah, this is
You said
recorded, so
yeah, you set the gradient to 0, right? And you saw from there.
not quite. But you could almost do this, but what I would say is, because it's undefined, that means this is 0. When 3y minus x is 0, this whole thing is undefined, right? Because you can't do it. Dividing by 0 is what we all know is undefined. If you remember that, we've mentioned that in lesson. So 3y minus x equals 0 to make it undefined. And I think that might answer your question, Latif. Because this gradient, yeah. Really, the other gradient, when it's flat this way, is when it's 0, horizontal. So once we've got that, that's to unlock the question. We've got y equals a third x, then the original equation. So we sub that in as a simultaneous equation. And then solve from there. Oh, yes, and it is 6:01, so you can break your fast now. It is sundown is 6:01 on my watch, so yes. Right,
sorry,
does that,
Thanks, sir. Thanks for the
does that
lesson.
make sense though?
Yeah, I got that, but I used y equals x instead of y equals 3 or a third.
Okay, what coordinates did you get for P?
Well, no, I didn't. I got minus 5, 5, but then yeah, I should have used the other one. But yeah.
Yeah,
Thanks.
but that's the key to unlock it. That's fine. So
Yeah.
once you've got this, you can unlock this, and it's just using. Obviously, you multiply out. You can simplify to 2 over 3x squared, because these are all terms of x squared. So times by 3 divided by 2, x squared equals 75. So you get your x as plus or minus 5 root 3. Now that's, can you see that will give you your P and your Q coordinates of x, but it's asking for P. P's on the left, so clearly you must use x equals minus 5 root 3. It's on the left. Sub that into your equation here to find your y, and then that's what you get. And hopefully that will make sense to you all. Now part C is just briefly explain, and this is actually the last question we finish on. So C, this is when we use what Latif said. We set the gradient to 0, because when we've got set the gradient to 0, that normally gives us a maximum minimum point, right? So you just need to explain set dy dx to 0. You don't need to do the whole working out, but just say, and so solve basically y minus x equals 0 when you set that to 0. So set y equals to x, and then, you know, substitute in here, but you don't need to do the working out. You just need to write that, and that is your one and final mark. And hopefully that was super useful for you. And if we have any questions, let me know. And that was the last question. So, hello, what?
So I don't really understand why you did 3y take away x equals 0. Like, I don't know why, how.
Okay, so do you remember before when I've said if anything on a graph and you divide by 0, that's what we call it's undefined, right?
Yeah.
Oh, well done, Alice. So these points, asymptotes, are undefined regions.
Mm-hmm.
So the only way that this can be undefined with the information we've got is this bit here. Can you see my arrow?
Yeah.
So, because anything divided by 0 on a graph is not defined, because you can't, undefined means you can't show it on the graph, which P
Okay.
can never be this. So that must be 0, basically. That's literally the only way with the information that you've got to doing it. And that's why that part B is like a tough one. I imagine most of the country did not spot that and would have only got 4. Yeah. And you can see the difference between what Latif said. Furthest north, well, you use your maximum and minimum values of dy dx equals 0, which is obviously because a 0 gradient is actually this way if you think about it.
Mhm.
Across, isn't it? Yeah, because it's
Okay.